All right, so here's what we're going to look at. We're going to look at why people say the rich get richer, okay? So this is often a hot button issue amongst political circles and things of that nature. And what I'm going to give you is sort of the mathematics behind it, okay? Often people will say, well, it's a terrible thing that the rich got richer, or it's a great thing that the rich got richer, or something like that. I'm going to give you some of the mathematical tools of why it tends to be that rich people get richer quicker than poor people do. All right? Now, again, what I'm not doing is I'm not saying a blanket statement. I'm not saying that that's bad. I'm not saying that that's good. And I'm not saying that always rich people get richer, because we'll see later that obviously, or we've seen obviously, that there are situations in which you invest a smaller amount, you can get a bigger amount. But as a goal, or as a overall observation, the rich tend to get richer faster than the poor do. All right, so the first and most obvious reason is multiplication. All right? Now, I hope you know, again, I'm not trying to do anything political here. Multiplication is as basic as it gets. When you multiply bigger numbers, they're going to get bigger faster. Okay? And remember, in our formula, principal is being multiplied by this 1 plus r over m to the mt. Okay? So there's this implicit multiplication going on. It's explicit multiplication, actually. So because of multiplication, because interest grows by multiplication, rich people tend to get richer. Now let me give you an example. Let's say, for instance, we'll call it a poor person and a rich person. Okay? Now the poor person only has $2,000, and so that person puts that all into a stock. And it doesn't matter which stock it is, but let's just say stock. And let's assume that stock grows at 6%. That is 6% interest. We're going to say compounded yearly. Now we're going to say that the rich guy invests 100 times more than that. So 200,000. Now that person is going to invest in the exact same stock. So the stock is going to still grow at 6% interest, compounded yearly. So let's fill out a table sort of describing what's going on. And again, I'd like you to push pause, fill out the table on your own, and then I'll come and fill out the entries as well. Okay, so hopefully you've done that. And basically, like I said, so poor person starting with $2,000. Okay, after a year, 1.06, right? He gains 6% interest, or she gains 6% interest, and the poor person will have $2,160. After 5 years, you should have gotten that 2676.45. Okay? After 20 years, we're going to get $6,414.27. Now it turns out did I say? I am sorry. I wrote that down wrong. 2120 up here. 2120 after a year. Excuse me. So 2,120, not 2,160. Let's look back at that. So after a year, the rich person actually, again, 1.06. So that rich person is going to get 2, 1, 2, 0, 0, 0. Notice that this is just this is just 100 times what the poor person has. So while the poor person gained $120, the rich person gained 12,000. That's 100 times the 120. So we can see that that transfers to each of the entries. And you'll end up with, excuse me, I typed in the wrong number again. $267,645.12 after 5 years for the rich person, and $641,427.09. Cool. So basically 100 times. And this is always going to happen. Remember that we said if you double the principal, then you exactly double the amount you're going to have. Well, if you do 100 times the principal, you're going to have 100 times the amount. So while they each gain 6% from year 0 to year 1, one of them gained 120, the other gained 12,000. So basically, if a person can afford to invest more, then they're going to get higher amounts on their return if the money grows. So this is what I said. If things grow, then those with the most invested will get the most rewards. I mean, that's the impact of multiplication. And again, multiplication is not a crazy conspiracy. It's just what it is. Now, the other side of that is true as well. Okay, and so this is the one thing that you always have to take into account when you're talking about, well, somebody made a lot of money. It's the opposite side. Because if you invest $200,000 and things get smaller, then that rich person who invested a lot of money is going to lose the most. All right? Let's just say we lost 100%. Well, the guy who invested $2,000 only loses $2,000. The guy who invests $200,000 loses the entire $200,000. So if things get smaller, then the investor who put in the most loses the most. And so this is the sort of risk and reward. Oftentimes people will say if you risk a lot, then you get big rewards. But you also can get big losses too. Okay, and that's the idea. And by the way, again, all we're doing is we're saying what the impact of multiplication is. Now, by the way, there are those who will say we should, make a system where people get closer to each other. Okay, and that's a hard thing to do based on the impact of multiplication. The only real way to do that is the second option, is to make things get smaller, which is again not good for anybody. All right, the other thing here is the impact that one of the reasons the rich get richer is the impact of exponential versus linear growth. Now, exponential growth is growth by multiplication, and we see that in the interest formula, because if you're gaining 6% interest, then you're taking 1.06, and you're taking another 1.06. We usually represent this by exponents, and then you're taking another 1.06 and another 1.06. So after 4 years of gaining 6% interest, that's 4 different multiplications. Linear growth is growth by addition. So basically, if we add on 10 each time, we do 10 plus a 10, plus another 10, plus another 10, right? And by the way, this one can be simplified as 1.06 to the 4th power. This one can be simplified as 10 times 4. So when I say growth by addition, because you see a multiplication here, don't assume that that's really growth by multiplication. That's just addition. That is just repeated addition. 1.06 to the 4th is just repeated multiplication. So let's take an example of exponential versus linear growth. So start with $100,000. We're going to have each person, we're going to have 2 people, start with $100,000. Now the linear person is always going to gain an additional, let's say, I wrote the 100 because I copied and pasted, but let's say that they gain $50,000 each year. All right. Now the exponential person is going to gain 10% each year. Now if you think about this, 10% of 100,000 is 10,000, right? So the exponential person is starting out with a lower amount of growth. But we'll see what's going to happen year in and year out. So the linear person is going to have 50,000. Exponential person is going to have 10% growth every year. All right. So basically this is what's going to happen. I want you to figure out how you would calculate the different amounts that the linear person is going to have after 5 years, after 10 years, 20, 30, and 40. And then see how much the exponential person is going to have after each of those years. Now, I didn't say how fast this is compounded. It says 10% each year. That's a yearly compounding rate. So take a few minutes to do that. So hopefully you've done that and you've calculated. I'm going to calculate lots of things here. So I'm going to use my calculator real quick and just type in what I want. So the linear person, I said, whoops, I didn't change that already. I said they're going to gain 50,000 per year. So after 5 years, they would have gained 5 50,000s. All right, so you'd take 100,000 and you'd add on 5 50,000s. Now that gets you to 350,000. Hopefully you caught on what we're doing here. Okay. Now if we did the same thing for 10 years and 20 years and 30 years and 40 years, what we're going to see is that, well, first off, 10 years is going to be 600,000. 20 years, we're going to get 1,100,000. 30 years, you're going to get 1,600,000. And then 40 years, you're going to get 2,100,000. Okay. Now, by the way, again, I'm going to write that right up here at the top. What I'm doing, I'm taking my initial 100,000, and then I'm adding on the number of years. I'll put that Y, and $50,000 each year. So basically, you're adding on $50,000 per year. So if you do Y is equal to 5, that gets you 5 years and 350,000. Y is equal to 20, then that'll get you 1,100,000, and so on and so forth. All right. Now the exponential person works differently. The exponential person is going to gain 10% each year. So this is where our formula comes in. So we're taking 100,000, and we are going to want to gain 10%. Now gaining 10% means 1.10. If I'm doing this yearly, it's 1.10. And then I'm going to take however many years we deal with. Okay? Now, basically, when you do that, so we're going to start putting in different values for your Y. Start with the value for a Y of 5. So what I would have gotten after 5 years, or what the exponential person would have gotten after 5 years, is $161,051. So it is much lower after 5 years still, because again, 10% of 100,000 isn't much. But let's keep going. After 10 years, you're going to get $259,374.25. I'm not going to write the 25 cents just so that I have room. After 20 years, I get $672,700, and if I round this to the nearest dollar, it's 750. After 30 years, you all of a sudden get 1,744,940 and 23 cents. Okay? So all of a sudden after 30 years, the exponential person has surpassed the linear person. And it's even more dramatic in the next 10 years. We have 4,525. So 4,525,926 if I round it to the nearest dollar. Like I said, most of the time on the test you should round it to the nearest decimal place. I'm just rounding it to the nearest dollar here so that I have room to write. Now the point of all this is to say and to point out that yes, even if the exponential person starts out by making lower amounts, eventually exponential growth is going to catch up and surpass linear growth. Now, what's all this mean to rich and poor people? Well, basically, those who invest in things like stock markets or bonds or treasuries, they get exponential growth. So they're exponentially growing their wealth. Linear people, if you're just relying on a paycheck year in and year out, and you don't ever invest, those linear people are growing by fixed and finite amounts, where the exponential person is always going to surpass them eventually. Okay? So the takeaway, the impact, again, I'll say it this way. Adding the same amount year after year doesn't get you as rich as gaining interest. And when I say that, I mean over the long run. Obviously, adding an amount over 5 years is sometimes better than getting interest over 5 years. But if you take enough time into account, doing exponential growth over the long run gets you to higher amounts over the long run. Okay? And by the way, as far as this applies to you, that means you should be investing as early as possible. Don't, buy the TV or buy the fanciest car you can afford. It's better to buy a quality car and then invest the remainder of what you could have spent. Okay? Now, there are other reasons that I don't want to get into every single reason, and it could be a drawn-out nightmare. But there are some other reasons, and I'll probably ask you on some forum questions to talk about this a little bit. One of the other reasons that I want to mention is that oftentimes rich people don't have to begin with lots of debt. Most people, most middle-class people, when they buy their first house, they use a mortgage, either a 30-year or a 15-year mortgage, to actually buy a house. But if you start out with enough money and you can pay for a house, you don't have to begin with that debt. So not only are you not paying interest on the mortgage, but that money may be going, that you would have paid into the mortgage, is going and actually gaining money. All right? So not having to begin with debt is actually a much bigger deal than it seems out front. Okay? The other thing, one of the other reasons, is there are often times that rich people will have better access to higher payouts. Okay? There are things called hedge funds, and you've probably heard of hedge funds. These are investment tools that, in fact, you can't get into if you're poor. I mean, it's illegal for a hedge fund to have you invest unless you have a certain amount of money or a certain amount of assets. And we saw how interest rates affected things. So if a poor person's highest interest rate they can get is 5%, and the rich person's highest interest rate is 10%, well, that's a big deal, as we saw earlier, right? Doubling the interest rate from 5 to 10 actually more than doubles the interest payouts. Okay? And there are others as well. This isn't an exhaustive list. Now, again, I hope that you understand sort of the mathematics behind it, how this works, why somebody with more money to start out with tends to do better than those who don't start out with as much money. And like I said, when I say the rich and poor, I don't mean this as a universal, because there are many, many poor people who get rich, and there are many, many rich people who end up poor, either by good decisions or bad decisions in their life or lifestyle.